Hello everyone, I'm Milind and this is my presentation about the sensor technology, and my topic is sustainable manufacturing of the sensors onto the soft system using the self-coagulating, conducting and Pickering emulsion. I know that this is sound more complex, but the idea behind this is not that much of complex, and this is the publication of the research group by the Yale University, which is published on the uh, th- March of 2020. And this is the area what I'm going to cover in this presentation: brief introduction and the problem and the proposed solution and the results and the conclusion. So first we look at the introduction, the what is the sensor. And sensor is the device which can be measure the physical properties like a temperature or a force. So this sensor technology is evolved in the last decades, and now it's coming up to the material level. The composite material confined sensors are the commonly used in the nowadays, and in the most probably in the biomedicine, sports and the robotics and the apparel industry. So in this figure you can see that the one of the application of the soft robotics application of these sensors. And normally this composite based sensor consists with the two parts. The first one is the polymer matrix and the other one is the conductive filler. So this conductive filler is the mainly focus on the giving the electrical resist signal according to the deformation of the body part or angle of the mechanical part. So it gives the electrical resistance or a capacitance according to the deformation. So because of that, we use these sensors in the more wearable devices and the soft robotic application. Here you can see that in this figure, the sensor is used to measure the angle of the knee and also the angle of the fingers and the angle of the elbow. The what is the problem with this kind of sensor technology? The printing the composite material generally entails with the use of the solvents such as the toluene or cyclohexane to dissolve this polymer resin and thin down the material to the printable viscosity. But however, the solvent cause the swelling and decomposition of the base material, uh, and also the most important thing is it is going to be make the more health hazard like a health toxin for the usage. In this figure you can see that the when we use this one, it's damage the base material and create the more swell and the decomposition in the base material. So this is helps to uh, these conductive fillers are not distributed among the base material more uniform way, and this is create the hysteresis error in the sensors. So then the group is coming with the idea called self-coagulating conducting Pickering emulsion. So here they use the uh, carbon black nanoparticle as the conductive material, and the polymethyl dihexane as the resin. And the most important thing is they use the ethanol as the solvent. So when it's use the ethanol, it is more uniformly distributed among the base material, and when it's evaporate it is not going to be damage the base material as in the previous cases. So in this example you can see how it's work. So first we apply the ethanol base our solution into the uh, top of the balloon and waiting for the evaporation, and you can see that it is not going to affect to the balloon. And but in the conventional system we use the cyclohexane, you can see that the balloon suddenly pop out because of the high toxin about the in this composition. So final result, we can come to the conclusion. This Pickering emulsion, ethanol based Pickering emulsion is creating a conductive composition which is easily print on the soft system, and this Pickering emulsion system is developed in the uh, high sensitivity and the negligible high uh, aesthetics, which is highly desirable properties of the most wearable technologies of the soft system. And This is create the have to knee pads and the cotton gloves, and also the apply the soft skin in the robotics soft robotics field. And this technologies helps to manufacture in the large scale of the sustainable high performance sensing technology in the soft robotics in the coming of future. And these are my references, and thank you for the listening, and I'm waiting for your question, and thank you all.